Hello, ladies and gentlemen. Welcome back to my channel. This is Math to the Point, and in today's video, we're going to be talking about how to add and subtract like terms. So we have basically two steps. Step one is to identify your like terms and then group them. The second step is to add and subtract only the coefficients of those terms. So let's begin with this example, which is example one. So I'm going to apply step one, which is the group the like terms that we have on this problem. And again, like terms, ladies and gentlemen, are basically terms that share the same variable and the same exponent or power on the variable. So if you haven't watched my video about how to identify like terms, please do that first and then come back to this video so that you can understand how we are identifying the like terms. But here I have a pair of like terms, which are 3x to the power of 2 and then positive x to the power of 2. The second pair of like terms, I'm going to circle them in orange, and those would be positive 4 and negative 1 because those are just integers. They don't have a variable. So technically speaking, I can add them or subtract them. So they count as like terms as well. Lastly, I'm going to be circling this negative 7y to the power of 3 and the positive 2y to the power of 3 because they have the same variable, which is y, and the same power on the variable, which is 3. Okay, so now that I have them all identified, I'm going to just place them back to back down here to begin adding and subtracting. So we have 3x to the power of 2 plus x to the power of 2. That's the first pair. The second pair is plus 4 and then the minus 1 from here and here. And then we have the last pair, which is negative 7y to the power of 3, and then the positive 2y to the power of 3. So all we have to do at this point is just add or subtract the coefficients. The coefficients, ladies and gentlemen, are basically the terms that appear on the left of the variable. For example, this one is a 1 because we don't see it. In mathematics, we sometimes omit the 1 when we multiply a variable like that 1, but in reality, we still have it. We still have this 1x to the power of 2. Okay, so we begin this process. We add 3x to the power of 2 plus 1x to the power of 2. You end up getting just 3 plus 1, which is 4. And then the x to the power of 2 is not going to change because that belongs to the two like terms. Next, we're going to be adding plus 4 minus 1, but in reality, that's subtraction because this one is negative. So you're basically subtracting 1 from 4. That will give you a positive 3. And then next, we're going to be subtracting again negative 7y to the power of 3 and the positive 2y to the power of 3 because this one is positive and the negative 7y to the power of 3 is negative. So when I subtract my coefficients, I get negative 7. So I'm going to put it here, negative 7 plus 2. I just add or subtract the coefficients, which in this case give me negative 5. And we just put the y to the power of 3 here. And this is the final answer. Now, if you notice, a nice way to check that this is the final expression is just to see that we don't have any more like terms that can potentially be added or subtracted. All I have is terms with variables that have different letters, different powers, or in this case, we have a 3 that is just basically an integer. So that's the end of this problem. Let's get into the second one. So for the second problem, we'll be applying the same steps. So we have this expression here, and we'll begin. Again, step one is to identify those terms that are like terms. So for example, here I see that we have a 2p to the power of 2, which has the same power and the same variable as the 10p to the power of 2. Those are like terms. Then the next pair of like terms will be the 4m, which is positive. Oh, and in reality, we actually don't have a like term for m because if you notice, we do have terms that have the same variable, but they don't have the same exponent as this one. The exponent on this one is 1. It's just that we don't see it because it's omitted. But technically speaking, any variable that doesn't have an exponent on top, that exponent is actually 1. So this one is going to be lonely. We don't have any partner for this one. But then for the last ones, we're actually going to be able to combine them because they are like terms. They have the same variable m and the same power or exponent. So now let's organize them back to back. So I have 2p to the power of 2, and then we have the positive 10p to the power of 2. After this, I'm going to put the 4m plus 4m, and then we have the negative 8m to the power of 4 minus just 1m to the power of 4. And let's begin adding the coefficients. Again, 2 plus 10 only, the p to the power of 2 doesn't change, and that gives us 12p to the power of 2. Then we have the 4m by itself because that doesn't have any more like terms to it. So that's going to be that's going to remain the same. And then lastly, I want to show you that this is a really interesting expression because we have two negatives, right? So we have a negative 8m to the power of 4 minus m to the power of 4. And I know it's really tempting to subtract the 8 and the 1, which is the coefficient for the m to the power of 4. But in reality, you have to remember that this 8m to the power of 4 is negative, just like the m to the power of 4. So in reality, because we have these two negatives back to back, they're going to be adding. They're going to be combined. So technically speaking, what's going to happen here is that I'm going to be adding, because we have this expression in a more simplified way, and that's exactly the same thing as negative 8 plus minus 1, then we end up getting negative 9. So we add the negatives. So my final answer here will be minus 9 m to the power of 4. Thank you for watching the video. Have a wonderful day, ladies and gentlemen.